Write 4 cubed in expanded notation. In other words, what does 4 to the power 3 actually mean? What it means is 4 times 4 times 4. So we have 3 4s in a row multiplied together. Note what it does not mean is 4 times 3. Write 2 times 2 times 2 times 2 times 2 in index form. So our base number is 2. We have 1, 2, 3, 4, 5 of them, so the power is 5. It's worth noting that the large number is called the base, and the small number, which is a superscript up here, is called the power or the index. Write 2 cubed times 3 squared in expanded form. 2 to the power 3 means 2 times 2 times 2. We're then multiplying that by 3 to the power 2, which means 3 times 3. So the power here indicates 3 2's in a row, and the 2 here indicates 2 3's in a row. We want to write 24 as a product of prime factors. One way of doing this is to use a factor tree. Let's have a list of the first few prime numbers to help us as well. So 2 is the first prime, then 3 is prime, 5 is prime, 7 is prime, 9 isn't prime because it divides by 3, but 11 is prime, and so is 13. We shouldn't need to go further than that. So let's start with 24, and just think of 2 numbers that multiply together to give you 24. It doesn't matter which 2 you choose. So we might go for 6 and 4. I know that 6 times 4 is 24. Now what can we multiply to get 6? 6 is 2 times 3, and both 2 and 3 are prime numbers. 4 is 2 times 2, and these are prime numbers. So we've reached the end of the tree, and we can now say that 24 is 2 times 2 times 2 times 3. If we use expanded notation, in index notation, that's 2 cubed times 3. Write 108 as a product of prime factors. Again, the first few primes might help us with this. So we have to find 2 numbers that multiply together to give us 108. If I add the individual digits here, I get 9. So I know that 108 divides by 9. In actual fact, it's 9 times 12. Now 9 is 3 times 3. 3 is a prime, so we'll circle that. 12 is 4 times 3. 3 is a prime, so I'll circle that. And then 4 is 2 times 2. So these are primes, so I'll circle those. So I now have that 108 is equal to 2 times 2 times 3 times 3 times 3. That's expanded form, and if we wanted index form, that's 2 squared times 3 cubed. We want to find all of the factors of 24 by using a factor tree. We've already established that 24 is 2 times 2 times 2 times 3. Now, 1 is always a factor of any number, and so is the number itself. We can find the other factors by taking combinations of the factors in here. So just take a single 2, and 2 is a factor. Just take a single 3, and that's a factor. Take 2 of the 2's together. 2 times 2. 4 is a factor. Let's take one of the 2's with 3. 2 times 3 is 6, so that's a factor. Take all of the 3 2's together. 2 times 2 times 2 is 8. That'll be a factor. Take 2 of the 2's with the 3. 4 times 3 is 12, which is a factor. And if we just take all of them, that gives us 24, which we know is a factor. So we can find all of the factors just by taking all of the combinations of the prime factors. Find all of the factors of 225 by using a factor tree. So let's start with 225. I can see that 25 goes into 225, and it's going to go in 9 times. So 9 times 25. 9 is 3 times 3, and these are prime numbers. 25 is 5 times 5, and these are prime numbers. So 225 is 3 times 3 times 5 times 5. Now 1 is definitely a factor, and so is 225. I can see that 3 will be a factor. 5 will be a factor. Take both 3's. 9 will be a factor. Take a 3 with a 5, so 15 will be a factor. Take both 5's. 25 is a factor. We knew that from here. Take 2 3's together with a 5. So that's 9 times 5, which is 45. So that's going to be a factor as well. Take both 5's with a single 3, and that gives us 75. So 75 is a factor.